Welcome to the class, students. We'll continue the chapter biomolecules. This is second topic in biomolecule, carbohydrate. In part 1 you must have gone through, and this is proteins. So this is another your biomolecule. Proteins are a highly complex nitrogenous organic compound. So they are giant molecule, big molecules, and structure is quite complicated, complex nitrogenous. OC means organic compound. So since they are highly complex giant molecules, so they have very high molecular masses. They are polyamides. Amide, this group is amide. C double bond O NH2. This group is called amide group. So all proteins are here. They are polyamides formed from alpha amino acid. This alpha amino acid is this. This is amino group, NH2 group. This is amino group, and this is carboxylic group. This group is carboxylic. So this is these both are functional group. You know the law of nomenclature. Out of these two, this has a dominance over this. This is more reactive. This is above in the reactivity series. So this will get preference, and so counting will be from this terminal. And you know the carbon next to the main functional group is marked as alpha carbon. So this carbon is alpha carbon. So this amino group is attached to alpha carbon. So this is called alpha amino group. So this is amino acid R, one alkyl group. But important thing is this alpha amino. That amino group is at alpha carbon. So carboxylic acid, this is having carboxylic group as well as NH2 group. So you should know the structure of alpha amino acid. This is general amino acid, and this is your here. Thus all proteins are polymers of alpha amino acid. This is repeated over and over again, long chain. We'll see later on the structure more in detail. Then you will see that how amino acid structure is repeated. Link one alpha amino acid with the other, and a long chain compound is formed to give you protein. So they are considered, alpha amino acid is considered as the structural unit of proteins. All these points which I have written down here are important for examination point of view. Questions are set from these points. So structural unit of protein is alpha amino acid. You have to study more in detail amino acids. So amino acids are basic, fundamental building units of protein. They are structural unit, or you can say they are building unit. Their molecules, what is the special feature as I explained there? Molecules possess both an amino group that we have seen, NH2 group, and a carboxylic group. You have seen this a carboxylic group. Both these groups are present. Amino acids of protein. There are various kinds of amino acids. But when when amino group is at alpha carbon, then it is present in protein. Amino group may be at beta and gamma carbons also, but then they are not the part of protein. So amino acids in which amino group is at alpha carbon, they are building units of protein. So amino acids or proteins are alpha amino acid. So here I have written meaning is what? NH2 and COH groups are attached to the same carbon. This is the carbon, same carbon to which these two groups are attached. Okay. Then we come to the structure of amino acid. So as you know, they contain, first characteristic, they contain both an acidic group. Carboxylic group is an acidic group. So they contain both acidic carboxylic group and a basic amino group. So this is acidic part, this is basic part. So both of them are present. Then second point, these all points are very important. Questions are set from this only. In neutral solution means when pH is 7. When pH is 7, you know this is of water. When solution is neither acidic nor basic, when solution is neutral, pH is 7. Both these groups are in the ionized form, very important. At pH 7, they don't exist in the molecular form. This exists in the ionic form, this also in the ionic form. So ionic form of this is what you can see. It will liberate one hydrogen ion and will turn into carboxylate ion. This is your carboxylate ion. And proton. So this proton which is released from here is trapped by this lone pair of electron which is present on amino group, and a coordinate bond is established. You can see here NH3. This is called your ammonium. Okay, ammonium or rather positive ammonia. This is a amine group, ammonium actually it is, or cationic form of amino group. Okay, NH3 plus ion. Now, the second part, it is not ammonium, it is aminium. And so here, second part of this point, in neutral solution, that is in pH 7, amino acid forms a dipolar ion. This is most important point. Dipolar ion structure, which is called internal salt structure or Zwitter ion structure. Zwitter ion is asked almost every year. So in neutral solution, amino acid forms a dipolar ion. Dipolar means two poles, one side is negative, other side is positive. So see here, alpha amino acid, and here H is set free, this H is trapped by this. So this side we have NH3 plus and this side we have COO minus, as you have seen here. So this side negative charge, this side positive charge. So this is called dipolar ion or internal salt ion or Zwitter ion. Okay. So this is formed at pH 7. So it is having both your basic and acidic groups present. Therefore, that is here. If you see here, this is having high electron density region. This has low electron density region. So because of this, the Zwitter ion behaves both like acidic and basic compound. Will show reaction characteristics of acid, will also show reaction characteristic of bases, and so Zwitter ion is amphoteric in nature. This is only possible at pH 7. Property of Zwitter ion, isoelectric point. This is another important topic in this amino acid from which questions are asked. An amino acid exists as a positive ion in acidic medium. As a positive ion in acidic medium means like this: NH3 plus CHRCOOH. So when acidic medium, acid is added from outside, then this is NH2 part. This is amino group. So proton from another acid which is in the solution is trapped by this and is existing in the positive ion form. So it is no more Zwitter ion, it is amino acid, and as a negative ion in basic medium. So if we have basic medium, then this remains as it is, and here this will be having negative charge. So either it will exist like this or it will exist like this. Okay, this is when the medium is acidic. This form, negative ion form, when medium is basic. So in acidic medium, it is moving towards the cathode. Positive charge, so it is moving towards cathode. So on passing current, it will migrate towards cathode. So when medium is acidic, then amino acid molecule moves towards cathode because this positive ion is there. And reverse will be the phenomena on passage of current. If medium is a basic alkaline, when this is having negative charge, it will be moving towards anode. So in acidic medium, it moves towards your cathode. Yeah, this will be moving towards cathode, and in this case, medium is basic, then it will be moving towards anode. But at certain pH, the pH which is suppose intermediate of the two, okay, balanced, both acidic and basic medium is balanced, and that range is falling into this 5.5 to 6.3. Okay, less than this acidic, less than 5.5 is acidic, more than 6.3 is basic. So if pH of the solution is between this, then what is happening? That amino acid is neither moving to cathode nor moving to anode. Okay, so it remains there in the solution without being discharged at anode and cathode. So this pH at which these amino acids are not set free at cathode and anode, that pH is known as isoelectric point. So hence at a particular pH of the solution, the amino acid molecule should not migrate to either electrode and should exist as a neutral dipolar ion. So you have seen your Zwitter ion at pH 7 in the neutral medium. That is what? When the medium is here having pH so much, it is not like your one positive ion and negative ion. Instead, it will be having both of these ions present. That is your dipole, that is your Zwitter ion. So because of these two charges at this particular pH, this molecule will neither move to anode nor will move to cathode. So this is here. The neutral amino acids have isoelectric point in the range of this. I already have told you, you should know this range. At what range amino acid will exist as Zwitter ion. So it will neither move to cathode nor to anode when the medium is even changed acidic or basic on passage of current. Now the next thing is peptide. Peptide. So amino acids are the smallest building unit of the proteins, as you have seen in the solid state unit cells. Small structures which are making big crystal. And here you know that amino acid, the smallest structure, like if you take this wall is consist of piling of small bricks. So this is small bricks are the building unit of this wall. Similarly, amino acid is the basic unit structure of proteins. So when these amino acids are united together, 2 or 3 or more than that amino acids, here this is amino acid, 2, 3 or 4 or many amino acid may be same means all alkyl group are same, or it may be different, alkyl groups are not same, but it has to be alpha amino, this you keep in mind. Only there will be variation in the alkyl group. So here I have written, then it is called your peptide. So the compounds which are obtained by the condensation of 2 or more same or different alpha amino acids are called peptides. So when many amino acids unite together, then the molecule is being united by the process of condensation. Condensation is one of the methods of polymerization in which volatile substances are released. This condensation, if you go back to aldehyde chapter and ketone chapter, then there I have taught to you aldol condensation in quite detail, and there I have mentioned very clearly what this condensation means. So if you revise from there, then it will be clear to you. So condensation is the phenomena in which at least 2 molecules will be uniting such a way that one water molecule will be released from this or any other volatile substance. So in this case, water molecule is being released, and so this is one amino acid. This is another amino acid. This is R. This is R dash. R dash I have taken just to differentiate. This R may be same, maybe methyl here, or here methyl, then here may be ethyl. So amino acids which are combining together, condensing together, and on condensation when they release water, then the product which is obtained, so this is slided off if you remove OH and H out from here. So we will have NH2 CHR C double bond O. So this part NH2 CHR C double bond O, this NH, and then we have CHR dash COOH. So this is your dipeptide. When 2 amino acids have been united together by releasing a molecule of water, the product obtained is called peptide. Okay, since 2 amino acids have united, so it is dipeptide. And this bond is your peptide bond. I told you in the beginning, this is your amide group. This is amide group, okay. So from here again your COH is attached. So this is still your amide group, and since this bond is formed here between 2 amino acids, so this is called your peptide bond. 2 amino acids have combined, so dipeptide. 3 will combine, then tripeptide, and so on. So here this dipeptide has been formed. Now when this process is repeated over and over again, many molecules of same or different kinds of amino acid are condensing, then they are producing long chain your peptide, that is called polypeptide. So next we'll see so polypeptides. as I explained there, polypeptides are formed when many or peptide molecules are linked together, and peptide molecules are formed, as you know, by the union condensation of the more than 2 amino acids of same or the different kind. The important thing about polypeptide, you need to know that it is although very long chain, but it will have free NH2 group. Free NH2 group means not ionic form, and will also have a free carboxylic group. So one side amino group free, the other side long chain carboxylic group. So what you have to remember, that NH2 group will always is shown on the left side. Okay, this is method of presentation. Always NH2 group on the left side and COH group always on the right hand side. And the carbon terminal is called, has got two names. If it is attached to NH2 group, it is called N-terminal carbon. Okay, when we talk of this side. And the carbon is said to be C-terminal carbon when we are talking about the carboxylic group side. So right side carbon is called, same carbon it will be, right side carbon will be called C-terminal carbon, and left side if you start naming it will be called N-terminal carbon. So you should know that N-terminal carbon means to the alpha carbon NH2 group attached, and C-terminal carbon means to alpha carbon carboxylic group attached. Then longer peptides are polypeptides, that you know already now. But what is there? There is no clear line of demarcation between polypeptides and proteins. So proteins and polypeptide you cannot distinguish very clearly. Very long this chain of peptide, that is polypeptide itself is called protein, and polypeptides which have molecular masses more than greater than 10,000, they are referred to as protein. So you can well imagine how complicated and giant the molecule will be. So these are the points you need to learn. So proteins are the long polymers of amino acids linked together by peptide bond. I have mentioned about the peptide bond earlier. So these all are important points from this topic that you always remember for your exam. Now classification of proteins on the basis of molecular shape, that is the structure. Only two types you have to do. One is fibrous protein, other is globular. So first I will discuss here fibrous protein. Fibrous protein is a linear thread-like polypeptide. You have to learn this point. Linear, straight, thread-like polypeptide chains arranged or twisted to form fibers. So you have to mainly emphasize on linear threads, either arranged or twisted. Then polypeptide chain are held together by hydrogen bonds, but these hydrogen bonds are very strong intermolecular forces of attraction, very strong. So although they have hydrogen bonds, but they are not soluble in water. You have studied when hydrogen bonds are present, then the compound is soluble, but protein is not soluble in water, although it has hydrogen bond, because this hydrogen bond is very strong, so they are insoluble in water. Then they are stable to moderate change in temperature and pH. Little bit if you change temperature and pH, then there will be no change in their property. Examples of fibrous protein you have to learn. Keratin is a fibrous protein which is found in hair, skin, nails and wool of animals. Fibrin protein is found in silk. Collagen is found in tendon, and myosin protein is found in muscles. So now the second type of classification on the basis of structure that is globular protein. Second type of protein is globular protein on the basis of the structure. This is also made up of polypeptide chain which are folded to give a spheroidal sphere-like shape. The important thing is non-polar hydrocarbon, as you know, they have alkyl group. Hydrocarbon is non-polar group, lipophilic, not attracted towards your solvent. Non-polar hydrocarbon will be inside the chain, and polar group means amino and carboxylic group, they are polar. Polar groups which are water soluble groups, they will be outward. So outward will be amino and carboxylic group, and inward, inside will be your alkyl group. And so only your polar groups, NH2 group and COH group, they are forming hydrogen bonds, like in fibrous protein also, but here hydrogen bond is weak. There it was hydrogen bond was strong, here hydrogen bond is weak. This is the difference, and therefore they are soluble in water. Globular proteins are soluble in water because of weak hydrogen bond. You saw fibrous proteins are insoluble because of a strong hydrogen bond, and are sensitive to changes in temperature and pH. You saw that they are not being affected by a slight change in temperature and pH, but here they are sensitive. Little if temperature is changed or your pH is changed, they are denatured, their nature is changed. Examples here, all enzymes, these all are the examples of various your globular protein, all enzymes, insulin, antibodies, HB is hemoglobin, albumin, that is your protein of egg, and venom, that is the poison found in snake. Venom, these all are example of globular proteins. Now denaturation of protein. Denaturation means its property will be changed. So as you know, proteins are very sensitive to heat, acid, alkalis and electrolytes, especially globular proteins. And so these four conditions you should know. Temperature is changed, medium is changed, acidic or alkali, and certain electrolytes, if they are added, then also their behavior is changed. So when the soluble forms are, so here I make you just understand, when the soluble form of the protein, soluble form means when they will be in their litter form, ion. So then when in the solution of this protein, either we are changing temperature, we are heating it, or we are adding some acid or alkali or some electrolyte, then they are coagulating. Clotting is taking place, coagulation, they become thick, and so this coagulation is taking place, and so globular protein will turn into fibrous protein. Okay, so that fibrous protein which is insoluble, so it will look entirely different, and therefore this is insoluble and will be floating. So here I read for you, when the soluble forms of proteins are subjected to the action of heat, acids, alkalis or electrolytes, they undergo coagulation to form fibrous proteins which are insoluble in water. So soluble form of the protein becomes coagulated. The best example is your albumin egg, that white portion of egg. It is water soluble. Okay, and then when you heat it, it will be coagulated. If you put some acid, it will be coagulated. Bio student must have done this experiment in their lab. And this results in a change of physical and biological properties. This is important. So when they are brought in contact of globular proteins, brought in contact of acid, alkalis or temperature is changed, so their only physical and biological properties are changed. Okay, and that coagulated form, that clotted form, thick form of the protein, that is fibrous protein which has been formed, that is called denatured protein, and the phenomena is called denaturation. So important thing is that the process which leads to the change in the physical and biological properties of protein without affecting its chemical composition. So from globular they are turning to fibrous. Their physical and biological properties are changed, but the chemical composition remains the same. That is, peptide bond will remain the same. So that's all about protein. And student, my next topic in biomolecule will be nucleic acid.